Okay, I have 4 pieces of tile and I need to determine the area of each piece of tile. Now luckily all 4 pieces fit on one sheet of graph paper, so I can trace them all. But first I have to decide which ones I really need to trace and which ones I really need to just diagram. Well, the ones that are regularly shaped, like this triangle, I know that the equation for a triangle is 1/2 base times height. And obviously for a rectangle, the area is equal to the length times the width. Okay, so area is equal to these equations. But for these 2 tiles, they're not in any way exactly or uniform. I could break them down into rectangles and triangles by drawing lines on the tiles, but instead I'm going to do it a different way and I'm just going to trace them. In fact, I'm going to start by tracing all of the tiles. So I'm going to start right here and trace all of them. Again, for tiles 1 and 2, which are uniform, I really don't need to trace them. I just need to draw them somewhere, and I'll label them. This will be, I should do this in a different color. I'll call this tile 2. And let me just trace these in color here as well. So here we have tile number 1. Now for tile number 4, I'm going to try and line up one edge and one corner with a point so that it'll make my counting of blocks a little bit easier. Need to hold it in place while I trace it. So this is tile 4. And this one I'll start down near the corner. I'll start one block off from the corner. And I'll trace this one. This is tile 3. This one up here, which I traced in pencil, I'll go back and outline again. I should really use a ruler for this. Or I should say you should use a ruler for this. So each of my tiles has been traced. Now the next thing that I need to do is determine the area of the tiles. Now for tile number 2, it's a square. So I'm going to use math. So area is equal to length times width. So the length of this tile, I can get that from my ruler. I can measure, and I'll do this in centimeters. If I look at this as closely as I can determine, this appears to be 9.2 centimeters. So I'll label one side 9.2 centimeters, and the width of this tile, as close as I can determine, is, let's see, 6.2 centimeters. So now up here I'll do my substitution. I'll say 9.2 centimeters times 6.2 centimeters, running out of room. And I need a calculator for this part. I get 57.04 centimeters squared. Okay. Now I only have 2 significant figures here in each of my measurements, so I'm going to round this to just 57 centimeters squared. I might keep one extra digit, but right now I'm not going to do that. Now it's important that I call attention to these, because this is going to be transferred into my table, so I'm going to box my answer in here for later. Should probably be using something a little smaller than a Sharpie to do this writing, but I wanted it to show up clear for you guys. Now in this case, for the triangle, it's also a regular triangle. So for a triangle, area is equal to 1/2 base times height. So I need to know the base of this triangle, which I'm going to call this, and the height of this triangle, which I'm going to call this line right here. So I need to measure them. So I'll start with the base, what I call the base, and it will be 10.4 centimeters. So this is 10.4 centimeters, and the height of this triangle is, if I can line it up well, it is 14.9. So I'll label this on the inside 14.9 centimeters. I've shown my equation. The next thing I need to do is substitute. So 1/2 10.4 centimeters, should show my units if at all possible, and 14.9 centimeters. So this is 1/2 and I get 1/2 times 154.96. I haven't rounded this yet because I still have one more calculation to go. Divide by 2. I get 77.48. I'm going to leave that extra figure, 77.5 centimeters squared. So this is my area, and I'll box this in because this is going to my data table as well. Now for my other tiles, my irregularly shaped tiles, tile 3 and tile 4, I can't just measure their dimensions. What I have to do is I have to figure out what they are based on how many blocks their outline covers. Now I know that each of these boxes on this particular graph paper is 1/2 centimeter on a side. So a box that's 4 complete squares is going to be 1 centimeter squared. So really I just need to count these boxes and divide by 4. The way I'm going to count them, in this case, I'm going to use a highlighter. So I'm going to just highlight all the boxes that are full. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll do that for the whole box, and then I'm going to show you what to do for the ones that are on the edges. Now on the edges, this box is almost full, but not quite. Where's a box that would fill it up? How about this one? So between the two, that makes one box. Between these two, that makes another box. And between these two, that makes another box. So this right here adds up to 3 boxes. This is all a judgment call on your part. This is a whole box. I would call this almost a whole box if I added this. And this is a whole box if I added this. And this is a whole box if I added this. So we go on and do that for all the tiles, and we can count them all, and we end up, as we count, we can highlight them, or as we count, we can just use a little pencil mark. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we said 12, actually that one, this one and this one 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, and so on. So when I've counted all of these boxes, it appears to be about 104 boxes. So I can record that however I desire. I can say 104 squares. So the area is equal to 104 divided by 4 squares per centimeter squared. because I already determined that 1, 2, 3, 4 was a square centimeter. So I do that math, and I get area is equal to 26 centimeters squared. So for tile 4, the area is 26 centimeters squared. I'm going to do the same thing for tile 3 here, but I'm going to cheat just a little bit. What I'm going to do is I'm going to find a big chunk in the middle that's full of boxes. So this right here looks to be kind of full. So I'll just go from here all the way over to here. And I'm going to see how many boxes this would be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 by 1, 2, 3, 4, 5, 6, 7, 8, 9. So 16 times 9 is 144 boxes. So all of this right here is 144. So now I just need to count the remaining boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So now I'm going to have to start combining boxes. So these two together make 25. These two, this one and this one, may be 26. This one and this one, 27. This one and this one together, 28. This one is about a half, but maybe with this one, that'd be 29. These two would be 30. These two, 31. 32. And this looks almost like a full box. So 33, 34, 35, 36, 37, 38, 39, 40. What about these guys? Well, these guys were pretty small, so maybe this whole thing would be another box, 41. Now over here, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 4, 5, 6, 57, 58, 59, 60, 61, 2, 3, 4, 5, 6, 67, 68, 69, 70, 71, 72, 73, 74. So maybe these two together are 75, 76. These together, 77, 78, 79, 80. So I have about 80 more boxes. So 144 plus 80, I know that's a long count, that's 224 boxes. I'm going to record that up in here where we can write this down so everybody can see. So we'll have area is equal to 224, we'll call it squares. So area is equal to 224 divided by 4 squares per centimeter squared. So area is equal to 56 centimeters squared. So this number right here is the number that's going to go in our data table for tile number 3. 56 centimeters squared for tile 3. 26 centimeters squared for tile 4. Tile 2 is about the same size as tile 3, and tile 1, by far the largest tile, at 77.5 square centimeters.